So we are back with part B for the homework. I did the camera angle a little bit different. Please let me know, maybe leave a comment on the homework if you prefer the previous camera angle or this one. Yeah, just please let me know. So I'm going to go ahead and get into part B here, which is talking about proportional control. And let's see, this one, share. Then we'll do this. No. Alrighty, so for proportional control, basically, we're going to take our last code, but now we want to control the height of the third tank. And so the way we're going to do that is through proportional control, which is different than PID. There are a few advantages to it. One, it reacts faster than a PID controller. If you do it correctly, there's less oscillation. In this case, there won't be, but there are several advantages to proportional versus PID. And so first we're going to go ahead and set the height for tank 3. And so let's do H3 set point, which is going to be, we're going to raise it by 10%. So that's going to be 1.1 times the initial height. And then from there, we're going to do the constant, which will determine the oscillations, or not the oscillations. You'll see here. So for the KC, for now, let's put 1E, maybe -2, because that'll give us a pretty nice looking result. So now what we're going to go ahead and do is, so a proportional control is based off of the error. So we need to calculate the error, which is going to be the difference between the set point and the actual height of the tank. So we have H3 set point minus H3. So that'll give us the error. So now the Qin is going to be changed, or rather defined differently. So it's going to be the initial Qin plus the constant times the error. Now, let's go ahead and run this, and first we can see this is what it looked like initially. It was sitting about, well, actually, I'll go ahead. I'll graph it first. So we'll do that. Shift enter, shift enter, shift enter, shift enter. And as you can see, it reacts quickly. Faster than the PID did. Now, we can check the H3 set point, and that is 22.45 if we round. And this is at 21. Now, one of the main issues with proportional versus PID is with proportional, you will never actually reach your set point. It'll get to an approximate area faster, but you won't ever actually reach your set point. So something in the assignment is that I should talk about the sign. And the sign is important because it'll give you a negative height. So we don't want negative heights. It'll work. We can calculate stuff with it, but it isn't what we want. So there's also a certain point with proportional control, which, like I said earlier, part of the advantage is typically it doesn't oscillate as much. As you can see here, it's not oscillating much at all. However, it can, as I said. So let's see. Let's do to the -1. And we can see that it starts oscillating once we get the number closer to 0. So let's go ahead and do 0.1. I didn't really notice that. 1e to the -1 is 0.1. It's late. I apologize. So let's do 0.15. As we can see, the oscillations get bigger. So now let's go ahead and check maybe a little bit higher. Do 0.2. Now we can see it's oscillating bigger and bigger and bigger, and obviously not good. I mean, we can see it's still only going from 20 to 28 down to, okay, that actually is, I mean, for tank 1, that's a massive oscillation. But, so let's see if we can, we're looking for a point where it's continuously oscillating. So let's try 0.19, shift enter, shift enter, shift enter. That, it's still getting bigger, but that's pretty darn close to being consistently oscillating. Let's go ahead and make this 50, just so we can see how much it's really changing. So it is getting gradually bigger. And so that's 1.9. Let's try 1.8. Not what we're looking for. If we're looking for the point where it's oscillating infinitely. So let's try 1.85. Pretty close. 1.87 maybe. Also pretty close. 1. Let's try 1.9 again with the bigger parameters. See, that's when it starts going up. So it's between, let's do 1.89. 0.189. Maybe with the parameters that big, it's going to be really difficult to dial it into the exact point. But I think I'm making the point here that there is a value of the constant that will, did I just find it? I did, wow, look at that. So that's 0.188. And that could be different for different controllers. It is different for different controllers. But as I said before, the advantage of it is if you do an actual KC value that you're not trying to create the maximum oscillations like I am here. So if you do 1 e to the negative 2, negative 2, yeah. So it'll get there much faster. However, like I said before, our set point is 22.45, but we are only ever getting to 21. So that's the downside to a proportional controller, is that you'll never actually reach the set point. You'll get to your steady state faster, but you will never actually reach the set point. Probably should have included this with part A, but I had a few things going on. So, yeah, I'll see you for part C. Thanks.